most important process of metal because as you have seen the refresher course, the 12th refresher course, the participants of the refresher course on material science, where the third area of the refresher course is as industrial minerals and materials. So the metals and alloys are one of the most important areas where these metals have been employed in varieties of engineering materials, varieties of industries, including automobiles, civil engineering applications, marine equipments, aircraft equipments, chemical engineering, oil and natural gas industries. Uh, More importantly, it also finds extensive applications in medicinal areas in designing artificial implants for human body, transport carriers, power generating systems like thermal, hydel, and nuclear power generators, electronic equipments. So a varieties of applications you might have noticed these metals and alloys. So when you're looking into these applications of this material, so one of the major concern for the applicators of this material in these industries is the designing of the material, property of the material. So these materials are undergoing a deterioration in its properties. So therefore, understanding how it get deteriorated. So what are the properties are responsible for the deterioration of this property, that is corrosion of metal, and what is the environmental factors, what are the metallurgical factors, what is the mechanism involved in this process. All these things are most important uh, when we are talking about material science, because metals are most abundantly available in the form of the respective ores in the earth crust, and it is subjected to vast varieties of applications. So therefore, when you're looking into all these industrial applications of these metals and alloys, one of the uh, burning problem, as I told, therefore we need to properly understand these properties of metal and alloys um, in order to maintain the safety, preservation, conservation. All these things are most important in all these sectors. So in this concern, today my talk on corrosion of metals and alloys, in understanding the fundamental aspects of this topic, I think it is a more topic that I have selected for this today's talk for the refresher course in material science. As the third area, as I told for this um, refresher course is industrial minerals and materials. So in this today's talk, I am going to put before you some of the important basic aspects of this corrosion of metals and alloys with this uh, following viewpoints. So when we are talking about this particular process called corrosion of metals and alloys, we need to understand why the study of corrosion of metal is so. Is it that much important? That is the most important thing. As you are the participants of the refresher course from the different discipline, you may all coming from some of you may all participating from the chemistry background, physics background, material science background, electronics background, geology background. So in every areas, we need to understand why the study of corrosion of metal is that important. And the second thing is we must understand why metal is corroded. When metal is corroded, what is the mechanism? If it is so, what is the mechanism? So once you understand this, is it possible to measure the corrosion rate? What are the techniques we used? Because we need to adopt our, we need to develop a most precise technique for the measurement of this corrosion of metals and alloys. And also we need to understand the principle behind the measurement of corrosion rate. So using this principle, what are the methods that we are going to adopt? And finally, I am also going to touch in this today's talk on about certain corrosion control strategies. I'm not going to speak more on corrosion control strategies on today's talk, because I have one more lecture on 14th that I am going to talk to you about the present scenario in corrosion control strategies of metals and alloys. So with this viewpoint, today I am going to discuss few important things. Many of you may have come across all these things. More importantly, those who are participating from chemistry background, and may the other the disciplines, maybe from physics, maybe from geology, electronics. So you also come across these important things first, but understanding precisely this factor, this phenomenon of metals and alloy is the most important thing. Yeah, when you are talking about this important first point, why do we need to study corrosion? So there are plenty of reasons for the study of corrosion. I have listed some of the most important reasons, which are the burning problems in the present scenario in the industrial sector and also in various sectors. As you know, these materials are precious resources of any country. So these resources are dwindling because due to this burning problem. So we might have noticed in various areas like in aircraft applications, marine applications, in automobile applications, using transport carriers. So whenever you use any materials in these applications, one must be understand the designing aspects. The designing aspects requires the corrosion behavior of the materials used. So therefore, in all these sectors, before designing a particular component in these sectors, so one has to look into the corrosion behavior of these materials. So therefore, we might have noticed the various instances in the recent past, which includes crashing of civil and military aircraft, naval and passenger ships, explosion of oil pipelines and oil storage tanks, collapse of bridges, decks, and failure of drilling platforms and tanker trucks that has been noticed in the recent years. So therefore, uh, we also, this corrosion of metal also plays a most important role, as I told, in the designing of artificial implants in the human body. That also requires the proper understanding of corrosion and engineering. And last but not the least, another last important area where we found this the study of corrosion found to be a more important property, that it is a threat to the environment. So whenever a metal is getting corroded, in either it may be causes pollution in the aqueous media, pollution in the environment, in various kinds of environment. Keeping these five important views, so one must understand the study of corrosion is the most important, and understanding the mechanism of corrosion is also a most important in designing various components using metals and alloys in these industries. So therefore, with this context, the study of corrosion of metal also most important of safety of the equipment, economics, because you might have seen premature failure of bridges, structures. One of the major reasons because of this is corrosion. We might also notice the failure of operating equipments. So therefore, almost all countries all over the world, because it is an industrialization, using various different varieties of metals and alloys, are pouring millions of dollars for just preventing the metal from corrosion. So therefore, we found that in the data, the corrosion cost of corrosion annually in the US is over $1.4 trillion. In 2019, it is around 4.2% of US GDP. Also, the report in 2019 states an Indian economy also suffers a loss of around 1,75,000 crore annually. That is because due to the corrosion of metals and maintenance, it is around 2.5% of Indian GDP. So therefore, the study of metal and corrosion of metal is, I found it is a most important area in the metallurgical operations in the material sense. Yeah, I just put before you some of the incident that happened in the recent past. Uh, One of the most important reason that was reported for all these disasters is mainly due to corrosion. You might have noticed the Bhopal disaster that happened in December 1984. So one of the most important reason for this, the disasters, is the leakage of MIC, methyl isocyanide gas, highly poisonous gas, which is used as a pesticide in pesticides. So the leakage of this gas is mainly due to this storage tank, which is made up of steel. The inner part of the storage tank is damaged, which cannot be noticed from the outer surface. As a result of that, a small hole or small damage in this tank leads to the leakage of MIC. So as you know that thousands of people lost their lives, hundreds and thousands are still suffering. The report submitted by fact-finding committee after the studying all this indicated that the plant was not in good condition. Many of the machines are too old. That is the report submitted to the concerned authority. So just you look here, the other some important incidents. It is one of the recently happened incident in Andhra Pradesh in 2014, natural gas transmission pipeline blasts. So this is one of the most important area, the corrosion of metal plays an extensive applications. So this is the GAIL, Gas Authority of India, where the inner part of this gas transmission pipe is damaged because due to the corrosion that was not noticed on the outer surface. Therefore, maintaining these pipelines or equipments from the corrosion is a most important part, particularly in the gas transmission pipelines. As a result of that, the millions of dollars or millions of rupees lost. So not only that, many people lost their lives. So this, I think you might have noticed in the recently. Yeah, the same type of varieties of this type of natural gas transmission explosion occurs in all over the world. The one of the another important example is Carlsbad, New Mexico gas line explosion. It happened in 2000. It is described as one of the second worst in the history of the US tragedy. So this is also a gas transmission pipeline is damaged because of corrosion. Yeah, this is one more incident that is also because of the gas transmission pipeline of British Petroleum Oil Gas Pipeline, which is operated by US, where this is severely damaged the inner portion of this, the gas transmission pipe. Yeah, another most important area that is called aircraft application. So this is one incident that happened, which is popularly called Aloha incident, where it happened in 1988, April 28, 1988. A 19-year-old Boeing 737 aircraft operated by Aloha Airline, it lost the upper fuselage in the front plane at the flighting height of around 24,000 feet. So as a result of that, many people lost their lives. The reason behind that, noticed after fact-finding committee, says certain parts of the aircraft is damaged because of corrosion. Yeah, this is one more, the huge, the crude oil transmission pipeline operated by US, where the Canadian oil is transmitted through this huge pipe. So one of the most important contaminant of this crude oil is as a diluted amount of bitumen. So this bitumen is highly corrosive. So look here, you might have think why this, there are plenty of other materials, polymer based materials are used in oil and natural gas industries. So it is not possible to use this. So the metals are inevitable to use in oil and natural gas industries. Therefore, they are undergoing corrosion because of the corrosive constituents in the crude oil. So this is one important area. Yeah, one of the most important example is the application of this in nuclear reactor. So this is, I have get this diagram where one of the most important component of this nuclear reactor is the reactor vessel. So this reactor vessel is fed with the nuclear fuel, control rods, coolant, everything is there in this nuclear reactor vessel. So the one of the commonly used coolant in this most of the nuclear reactor is boric acid. So this boric acid is a culprit which is responsible for the corrosion of this vessel. As a result of that, so one such incident happened in the nuclear reactor in US called Davis Blessed nuclear reactor, where this the reactor vessel is damaged. I think you know the mechanism of nuclear reactor, the type of process occur in the nuclear reactor. If a damage occur, a small damage occur in this nuclear reactor vessel, you can imagine the type of disasters you can notice. That is also because due to the corrosive substances. This is another important example. The same kind of disasters happened in Mihama 3 nuclear reactor in Japan in 2014. That is called pipeline rupture caused by flow accelerated corrosion. So these are another important example. Yeah, this is, you see this inner part of the gas or water transmission pipeline. Of course, the outer portion of this pipeline looking fine, but the inner portion is severely damaged, the buried pipeline. So that causes a severe damage. So before you notice the damage occur in this pipeline. The more importantly, the metals and alloys are used as in various electronic components because the metals are very good conductors of electricity. So these materials in a humid atmosphere, in atmospheric conditions, causes a damage because due to the corrosion that leads to the resistance for the conductivity that also causes a short circuit. So this is one of the most prone part of the aircraft applications which is subjected to severe damage because of corrosion. Yeah, another important, the sector where the corrosion plays a most significant role is called marine applications, where some of the important components of these marine components are made up of certain metals and alloys. So these metals and alloys are also subjected to a highly corrosive electrolytes of seawater, which contains a large quantity of dissolved salts. Apart from that, there is the high buffeting waves. So all these factors are responsible for the damage of these marine components. So therefore, the marine applications, the corrosion of materials, I mean the metals or alloys, plays a most important role. So therefore, when you're looking into all these important, few important examples, we found that the study of corrosion of material or corrosion of metal is a most important part from the materials point of view. So therefore, today's my talk is restricted to the corrosion of metals and alloys, but not necessarily the metals and alloys are undergoing corrosion. Almost all varieties of metals are getting deterioration I mean to say it loses its properties. The deterioration in the sense it loses its properties, it loses its mass due to environmental effects. So it is a natural tendency. The process of corrosion is a natural tendency of the compositional elements present in the materials. So these, the materials or metals are returned back to their most thermodynamically stable state. That I'm going to tell you a little later, the thermodynamics of these materials. So as I told, my today's talk is restricted to only the metals and alloys. Not necessarily, there are plenty of other materials which includes polymers, plastics, rubbers, ceramic materials, concretes, bricks, and varieties of composite mechanical mixtures of two or more materials having different properties. They are also loses its property due to a different type of environmental constituents, environmental effects. So therefore, the corrosion of material is just losing its property. Because due to the various compositional elements present in these materials. So I told, of course, the metal or materials are getting deteriorated, loses its property because due to the varieties of environmental factors, because due to the elemental composition of the materials. The question here is why it is so, why the metal is getting corroded. As I told, almost all metals and alloys are chemically unstable with respect to the environment, varieties of environment. So the environment in the sense it includes a varieties of constituents. We commonly call it as corrosive constituents. The corrosive constituents may be in the gaseous state. It may be sometimes in the liquid state. It may be sometimes in the vapor state. So therefore, these corrosive constituents is inevitable in contact with these materials. Therefore, it loses its stability. So whenever it is loses or undergoing corrosion or loses its stability, it may occur by means of one of the important chemical process. This is what we call it as oxidation process. The oxidation process is mainly responsible because due to the presence of plenty of oxygen in the environment, corrosive environment. Okay. Therefore, there is certain driving force, so which causes the metal to undergoing corrosion. What is this driving force? So when you're just looking into the materials or metals used in varieties of applications, as I told, it may be automobile applications, it may be civil engineering applications, it may be in medicinal applications, a varieties of applications I made a mention. So all these materials which are available in the nature, in the earth crust, they are all man-made materials. They are not synthetically made materials. So these naturally available materials are originally present in the form of respective chemical compounds. As you know, they are popularly called ores. There are varieties of ores, iron ore, zinc ore, copper ore, varieties of ores. So these ores are called chemical compounds. So the metals are available in the form of compounds, maybe it's respective oxides, maybe respective sulfates, maybe respective carbonates, maybe respective phosphates. A plenty of different varieties of compounds are present. They are all the stable compound of their metals. They are thermodynamically stable. Look here, the stability. So these stable compounds are converted into a pure metals by means of various metallurgical operations. So when you are subject these ores into metallurgical operations, I think you might have come across the different steps involved in the metallurgical operations. It may be a purification process, it may be a refining process, it may be a reduction process, it may be smelting process. I think you have come across the metallurgical operation of iron, metallurgical operation of varieties of other metals. It is a very simple topic. So in all these metallurgical operations, what happened? The conversion of the chemical compounds of the metal, I mean, a ore into a pure metal, is subjected to a huge amount of energy. A huge amount of heat energy is supplied during almost all steps of metallurgical operations. So these the stored up energy, when you supply a large quantity of energy, you might have noticed in the purification of or obtaining pure iron from ore, we are supplying a very high heat energy, more than 1500 degrees Celsius. So all these metals, while converting ore into pure metals, a large quantity of energy is stored in these pure form metal. Therefore, whatever the pure metals we use it for various applications, they are all high energy stored metals. They are called thermodynamically high energy stored metal, energy rich metals. You know that whenever any species which has high in energy, they are highly unstable. They are going back to the stable state by losing its energy by varieties of physicochemical processes. The same thing happened in case of our metals, in case of pure metals. Whatever the pure metals we use, they are all thermodynamically high energy stored metals. So when these metals are in contact with certain uh, corrosive constituents, maybe gases or liquids or vapors, so they are tend to lose this energy, stored energy, by means of this process called corrosion. So this is the reason this is a spontaneous process that doesn't require any external supply of energy. Therefore, corrosion is a spontaneous process. It loses its thermodynamically stored energy. But certain metals like, as you told, gold, silver, other platinum, palladium, they are all available in the native states. They are stable for a certain extent. So this is the reason why the technical reason behind why metals is getting corroded. Yeah, once you understand why metal is getting corroded, there are varieties of theories which explains the mechanism of corrosion. I'm just putting before you few important, starting from a very basic acid theory to most accepted and presently accepted and well developed theory called Wagner and Trott's or local cell theory of corrosion. So there are four theories. The first one starting with acid theory of corrosion. The second one is chemical theory. Third is local cell theory, and lastly Wagner and Trott's. Wagner and Trott's, an electrochemist who proposed the most accepted theory. Yeah, it is. Let me see briefly. I'm not going in detail. Very briefly on all the four theories of corrosion. So, as this theory, acid theory itself says that the corrosion of any metal is because due to the contact of this metal with some acidic environment. Not necessarily when a metal is in contact with acidic environment like sulfuric acid, nitric acid, hydrochloric acid, carbonic acid. Not necessarily a direct contact of any metal with these acids, but there is a creation, there is a generation of these acid because due to the constituents of atmosphere. There are major constituents of atmosphere is atmospheric carbon dioxide, moisture present in the atmosphere, plenty of oxygen in the presence of atmosphere. Therefore, the presence of these three important constituents in the atmosphere is responsible for the generation of acidic components, mainly carbonic acid or bicarbonic acids. So the acid generated due to the presence of these chemical constituents in the nature is responsible for the metal to undergo corrosion and leads to the formation of some of the corrosion products like iron bicarbonate, iron hydroxycarbonate, ferric hydroxide. These are some of the important corrosion products which are formed because due to the corrosion of these metal in an acidic environment. This is a simple reaction mechanism. This is a simple reaction mechanism. How iron is get corroded in presence of atmospheric carbon dioxide, moisture, atmospheric oxygen. leads to the formation of the respective bicarbonate, metal bicarbonate, or this bicarbonate with excess of moisture and atmospheric oxygen leads to the formation of this compound, iron hydroxycarbonate. And this iron hydroxycarbonate with a plenty of moisture atmosphere leads to a stable corrosion product of iron, the ferric hydroxides. So this is one basic theory which was explained very first to understand the mechanism of corrosion, as it says that the corrosion of metal is mainly because of acidic environment. But it is not true. Only acidic environment is not responsible for the metal to undergo corrosion. There are plenty of other chemicals constituents are responsible, in spite of the fact that it was the first and foremost proposed theory. It is a proposed theory. So this, the corrosion can be controlled by preventing the contact of metal with the carbon dioxide. So if you remove the carbon dioxide from the atmospheric oxygen, you can prevent this for the formation of acidic environment. As a result of that, corrosion can be eliminated. So normally this can be achieved by using certain chemical compounds like caustic soda, lime. These are the very good absorber of carbon dioxide, so that the formation of acidic environment can be minimized. The second theory, after this, as I told, is a chemical theory, or it is also called dry corrosion. So not necessarily the acidic environment is responsible for the metal to undergo corrosion. There are plenty of atmospheric gases like mainly oxygen, halogens. H2 means halogen, maybe chlorine, bromine, iodine, oxides of sulfur, hydrogen sulfide, oxides of nitrogen, fumes of varieties of chemicals which are responsible for the metals to undergo corrosion, provided that the metals are in good contact or in good affinity with these atmospheric gases. So therefore, the extent of corrosion of any metal is depending upon the chemical affinity of a metal towards these reactive gases in a dry condition, in the absence of moisture. So in spite of all these, the oxygen is one of the most important constituent which is responsible for the most of the corrosion of substances compared to other gases and chemicals. So therefore, depending upon the type of gases involved in dry corrosion, we can call it as oxidation corrosion, where oxygen is responsible for the corrosion of metal, or we can call it as corrosion by varieties of other gases like chlorine, sulfur dioxide, hydrogen sulfide, oxides of nitrogen, since these gases are responsible for corrosion. And also called liquid metal corrosion, where the metal in the liquid state, the most importantly, mercury is one of the only metal which is available in the liquid state under normal condition, is responsible for almost all metals undergoing corrosion to form a respective metal amalgams. Yeah, the third theory, it is the most accepted, still it is using to prevention of varieties of metals, called local cell theory. Local cell theory, I think. So one must have a knowledge of, a very brief knowledge of electrochemistry to understand this local cell theory of corrosion. There is a formation of cells, electrochemical cells on the surface of the metal. So these cells which are formed on the surface of the metals are commonly called local cells. These local cells are created on the surface of the metal because due to one of the most important reason is heterogeneities on the surface of the metal. The metals are not homogeneous in nature. So while it is making, there are varieties of inhomogeneities, varieties of imperfections, disorders, hitches. So we commonly call this as heterogeneities. So this is one of the most important reasons for the generation of local cells, for the creation of local cells on the metal surface. So once these local cells are created on the metal surface, there is a difference in potential developed on the metal surface, on the same metal surface or the different parts of the metal surface, once the potential difference is developed, it acts as a local cell, a electrochemical cell. So this cell is responsible for any metal to undergo corrosion, was the theory which was well explained by local cell theory. So therefore, almost all metals, when they are undergoing corrosion in presence of varieties of corrosive environment, is set because due to the formation of the local cells. Millions and millions of local cells are formed on the metal surface. Once we call this is a local cells, millions and millions of the anodic region and cathodic regions are created on the metal surface. This anodic and cathodic regions are mainly due to, as I told, heterogeneities. The heterogeneities is from stress from welding other works, or it is from compositional differences on the metal surface, or it may be from surface irregularities while forming, extruding, and other metal working operations. So because due to that, there is a creation of cells, uh, electrochemical cells. And finally, the extension of the local cell theory of corrosion was well explained by this theory called Wagner and Trott's theory. So there is a small modification in this theory according to this Wagner and Trott. Of course, this creation of cells on the surface is essential for the metal to undergo corrosion, but the impurities and other heterogeneities are not so important factor for the creation of cells. The most important thing which was explained by Wagner and Trott is the corrosion of a metal is accompanied by a cathodic reaction. Whenever a cathodic reaction occurs simultaneously on the metal surface, there must be some cathodic material. The cathodic materials are corrosive causing materials, corrosive environment. So therefore, once a metal is in contact with the corrosive environment, there will be formation of corrosion cells, electrochemical cells, anodic and cathodic regions. So not because due to the heterogeneities, it is mainly because due to the corrosive environment, which are responsible for the metals to form a corrosion cells. So these corrosion cells involves the three important chemical process. So the one of the most important process, as I told, is anodic process called oxidation reaction. The oxidation process occurs at the anodic area of the metal because due to its very low potential, very low electrode potential. So once the anodic process takes place, the electrons are get released. These released electrons are flowing through the metals towards the cathode. So these electrons are get reduced. I mean, it is a cathodic reaction when it is contact with certain corrosive environment. So these are the three important chemical process, electrochemical process, which were responsible for the metal to undergo corrosion to form a cell, electrochemical cell, which was well explained by Wagner and Trott's. That is called Wagner and Trott's theory. Therefore, so corrosion follows basic laws of thermodynamics. It is an electrochemical process. So under controlled condition, it can be measured, it can be repeated, and it can also be predicted. So the corrosion process is accompanied by the formation of electrochemical process or electrochemical reaction, which involving two half cell reaction. In one half cell, anodic reaction takes place and another cathodic reaction takes place. Anodic reaction is the release of electrons, oxidation. The cathodic reaction depends on the nature of the corrosive environment. Depending on the nature of the corrosive environment, these are the three cathodic reactions: oxygen reduction reaction, hydrogen evolution from neutral environment, or hydrogen evolution also from acidic environment. So this is the mechanism of the corrosion reaction explained by Wagner and Rod. So this is an oxidation reaction where the metal is getting oxidized with the release of electrons. These electrons are then get reduced in presence of varieties of corrosive environment. It may be evolution of hydrogen in the absence of oxygen. It is an acidic neutral or alkaline environment. This is how evolution of hydrogen occurs. And this is the reaction occurs in the absence of oxygen. These are the varieties of cathodic process occurs in the electrochemical corrosion mechanism. So this is how when a metal, it is a metal like iron is in contact with a corrosive environment, some part of the metal because of its lower potential acts as an anodic region. This is an anodic region where oxidation occurs. These released electrons are moving through the metal, the electron flowing through the metal. So these electrons in contact with certain corrosive environment, say it is an acidic environment here, it may be sometimes neutral environment, they get reduced with the evolution of hydrogen gas. This process continuously takes place until the whole metal in contact with the corrosive environment is completely deteriorated by means of corrosion. Yeah, once you understand the theories of corrosion, the two important process occurs, anodic process and cathodic process. The anodic potential and cathodic potential of a metal plays a most important role for the severity of the corrosion. So therefore, this potential is called it as an oxidation potential, reduction potential. Together we call it as oxidation reduction potential. This anodic potential is denoted by EA, which combines with the cathodic potential denoted by EC. The total potential, it is E. If this total potential is positive quantity, then the reaction proceeds. I mean, corrosion reaction proceeds spontaneously. Therefore, the corrosion is a spontaneous process. So almost all metals has a unique value of this potential, the, the corrosion potential. They are called under standard condition. So this potential, we call it as a standard electrode potential, denoted by E naught. So this value, the standard electrode potential of metal under standard condition signifies the corrosion, nature of corrosion and the extent of corrosion in a corrosive environment. Therefore, the value of the standard electrode potential plays a most important role in understanding the severity of corrosion, the magnitude of corrosion. So this value of standard electrode potential that has been determined and tabulated in the form of table. So this is a table. This table is a standard table which is available in almost all literature. So this is the normal cathodic reactions of, I have selected few important metals. This is the respective standard potential value. Look here, the iron, I mean gold, the top of this is a gold having around 1.5. If you keep on move towards the bottom of this potential value is getting slowly decreases and it comes to a negative value when you almost move towards the bottom. Look at certain metals like potassium, sodium, magnesium, aluminum, so on. They are having a negative potential, negative value of potential. Any metal whose the potential, electrode potential is highly negatives are more prone for corrosion. They are most active metals. So the metals with more positive values are more stable metal, most stable metals. So the value of the standard potential decides the magnitude of corrosion in a non-corrosive environment. So I told you corrosion cells are formed on the metal surface. How corrosion cells are formed on the metal surface? The corrosion cells formed on the metal surface because due to varieties of metallurgical factors, These are some of the important metallurgical factors like composition, microstructure, precipitation, heat treatment, mechanical rolling, welding, work hardening, fabrication, installation. There are varieties of metallurgical factors are responsible for corrosion of metal. Apart from that, there are varieties of environmental factors. There are plenty of environmental factors like concentration of the corrosive environment, which is said to form a concentration cell, uh, environmentally induced stress corrosion cracking, hydrogen induced cracking. Certain microorganisms are responsible for corrosion, that is called MIC, microbiologically induced corrosion, temperature induced corrosion, mechanical, environmental induced erosion, galvanic, CP impressed current anodic dissolution. So therefore, there are varieties of plenty of environmental factors are responsible for the metals to form corrosion cells, anodic and cathodic environment. So depending upon the nature of the corrosive environment, we have a varieties of corrosion, because we need to understand certain corrosive environments are responsible for a kind of corrosion. Depending on the kind of corrosive environment, we um, classified the different classes of corrosion. Few important classes of corrosion called uniform corrosion, where the corrosion of metal occurs uniformly, where only one kind of corrosive environment is responsible for this type of corrosion. Number two is galvanic corrosion. So this corrosion occurs because due to the formation of a galvanic cell. It is one of the most important kind of cell, electrochemical cell, when two different metals, this is one metal made up of, say for example, copper in contact with the other metal, iron. If two different metals having different potential or in contact with the corrosive environment, a cell is created called galvanic cell. It is responsible for corrosion of metal. This is a differential aeration corrosion, or it is popularly called concentration cell corrosion. So when a particular metal is in contact with the corrosive environment of different concentration, so this particular metal is exposed to a lower concentration. This is exposed to a higher concentration. The lower concentration of the corrosive environment acts as an anodic reason. The other one is acting as a cathodic reason. So this is another type of corrosion. Pitty corrosion, certain microscopic defects, certain pits which are responsible for the metals to undergo corrosion. This type of corrosion is normally noticed in inner part of the pipelines, gas transmission or water transmission pipelines. Crevice corrosion. So normally this type of crevice corrosion is noticed in some of the automobile applications, where metals are in contact with metals, or sometimes metals are in contact with non-metals. In presence of corrosive environment is responsible for this kind of corrosion, crevice corrosion. Filiform corrosion. Look here, this is one of the most dangerous type of corrosion, because one of the most important protocol we followed for the protection of metal from corrosion is plating or coating, some organic coating, polymer coating, or metal coating. So while coating a metal, we need to take a most important precautions. Suppose if any micro defects on the coated, the corrosive electrolytes are penetrate through these micro defects, so that the entire inner portion of the metal is severely damaged because due to the corrosion. So therefore, this kind of corrosion called filiform corrosion. The intergranular corrosion. So normally this type of corrosion is occurs on adjacent to grain boundaries or metal alloys. Yeah, this is one more kind of corrosion called stress, because due to the stress, there are micro pores or micro cracks are developed, sometimes which we cannot be noticed by our naked eyes. There are micro cracks. So these cracks are severely damaged because this cracked portion of this metal acts as anodic region. The remaining portion acts as a cathodic region. Therefore, this corrosion is called stress corrosion. Corrosion fatigue. Look here, this the fatigue portion of the inner part of this the gas transmission pipeline. This is also prone for corrosion. Phytic corrosion. Normally, this kind of corrosion is noticed in some automobile operations. This is a high-speed rotating wheel is subjected to a corrosion called phytic corrosion. Erosion corrosion, because the erosion of certain corrosive electrolytes causes severe damage for a metal. Look here, this portion, the erosion of liquid at this portion of pipeline is very high. Therefore, this portion is severely damaged compared to the other portion. This is called erosion. The same application we noticed in some automobile applications. De-alloying. De-alloying is another kind of corrosion where the alloys get depleted, because one of the important protocol we follow to minimize the corrosion is making the metal alloy. So when the alloy portion of the metal is depleted, the metal is undergoing corrosion, a de-alloying process. Yeah, corrosion in concrete. So because plenty of varieties of reinforcing materials are used in concrete structures. So therefore, this is undergoing severe damage because due to highly corrosive environment. Microbial corrosion is another important form of corrosion where certain microorganisms are responsible for the metals to undergoing corrosion. Because due to the activities of microorganisms, it generates certain acidic environment, alkaline environment. So these environments are prone for corrosion. So therefore, keeping in view of the different forms of corrosion, so now let me briefly looking into varieties of different techniques we use to measure the corrosion rate. I mean, we call it as a kinetics of corrosion. So because the measurement of corrosion of a material or a metal in a known corrosive environment is a most important task for metallurgist or chemist or any other scientific background. So when we looking into the different techniques employed for the measurement of corrosion rate, normally we followed these three important technique. One is called a mass loss technique. It is also called gravimetric technique. Number two is a chemical technique. And the last one is, and the most important is electrochemical technique. So this mass loss is based on the quantity of the metal lost during corrosion. So once a metal is getting corroded under a known corrosive environment, certain portion of the metal lost its property. I mean, it is converted into respective ore or compound. The metal which is converted into compound is lost. The quantity of the metal which lost is taken into consideration in the analysis of the corrosion rate, that is called mass loss technique. While in chemical technique, certain chemical techniques, physicochemical technique or analytical techniques are used to analyze the material which is converted into compound as corrosive compounds. There are plenty of chemical techniques which may be electrochemical technique, which may be photochemical technique. There are varieties of spectroscopic techniques are employed to analyze the quantity of metal which lost by corrosion. And the most important, as I told, because the corrosion follows the electrochemical principle, we popularly use to measure the corrosion kinetics most accurately by electrochemical techniques, by using a potentiodynamic polarization technique and an electrochemical impedance technique. This polarization technique is followed by either a Tafel extrapolation method or by linear polarization method, whereas the The electrochemical impedance technique is employed to measure certain impedance parameter, certain coating resistance parameter, certain charge resistance parameters. A most important sophisticated equipment is used for the measurement of all these parameters in analyzing the kinetics of corrosion with this technique. Yeah, this is a mass loss technique. We followed the protocol like this. So once you measure the quantity of mass loss, keeping in mind the quantity of mass loss, we can calculate the corrosion rate by using the simplified mathematical equation. Yeah, in polarization technique, I will just give you some brief background about the principle involved in the measurement of polarization technique in the measurement of kinetics of corrosion. It is a measure of polarization behavior of the metal. So when a metal is undergoing corrosion, I mean a transfer of electron takes place. The corrosion is an oxidation process. Transfer of electron takes place. The extent of transfer of electrons is a measure of the current, that is called corrosion current. So therefore, almost all metals under a standard condition are at equilibrium potential. That is called standard equilibrium potential. So whenever a metal is corroded in a corrosive environment, the potential changes from the equilibrium value. This process of changing the potential from the equilibrium value is called polarization. The polarization may occur in the cathodic direction because there is a change in the cathodic polarization, or it may occur in the anodic direction. I mean, it may change in the anodic reaction. So the extent of change in the cathodic polarization or extent of change in the anodic polarization is measured by means of polarization technique. So in this technique, what we use here is, so in an external circuit, we accelerate this anodic reaction by shifting its potential in the cathodic direction or by shifting its potential in the anodic directions. So once we supply external current, you keep on measuring the potential and you just analyze an anodic polarization and cathodic polarization in the form of a curve, in the form of a plot. So this is how we plot a graph. This is how we plot a graph. This is one such technique. I will tell you this Tafel plot. So this is one of the technique called Tafel extrapolation plot. The two parameters, one is called current. We normally use the logarithm of current in milliamperes or amperes. And in another, we call it as potential. So these two parameters are the most important in the measurement of corrosion kinetics by means of polarization technique. So when you keep on changing the current, the potential also varies, changes. So once you get a set of data of current as a function of potential, so we get a polarization behavior, which is represented by means of a curve like this. So the upper curve is indicating the polarization behavior of anodic reaction. This is the anodic reaction of iron where oxidation occurs. This is the polarization behavior of a cathodic reaction in acidic environment where hydrogen evolution reaction occurs. So this is called anodic polarization curve. This is cathodic polarization curve. So if you extrapolate these two curves, the point of intersection towards the x-axis, we call it as a corrosion current. The point of intersection towards the y-axis gives you the corrosion potential. This corrosion current plays a most important role. This can be used, i.e. corrosion, for the calculation of corrosion rate, for the prediction of corrosion current. With this simple mathematical expression that we have derived with the help of Faraday's law of electrolysis. Because the dissolution of metal follows the two laws, Faraday's laws of electrolysis, first and second law. The mathematical form of the two laws can be simplified to get this final expression, which includes WE, that is the equivalent weight of the metal. That is the I corrosion can be obtained by this plot. and the D, the density of the metal. So one of the most important accepted theory which normally people employ to understand the kinetics of corrosion. Apart from that, we also used to measure the corrosion rate by impedance technique, electrochemical impedance technique. So I just give briefly about the impedance behavior of the metal. So normally in AC, I mean in DC theory, direct current theory, the ability of the circuit element to resist the flow of current is explained by Ohm's law. So this is the Ohm's law. I'm not going to explain that. Whereas in AC theory, alternate current theory, so instead of the resistance offered by the flow of current, we use a term called Z in the Ohm's law, that is called impedance. Impedance is a measure of the resistance offered by the flow of current, the AC theory, I mean alternate current. So this parameter is taken into consideration in analyzing certain important corrosion parameters. So these are certain important, this is how we can make the skeleton to understand these certain important parameters like barrier performance, corrosion resistance behavior, water uptakeability, delamination. There are varieties of important parameters, corrosion parameters can be obtained by this technique. This is a simple experimental setup for the both the electrochemical impedance technique as well as polarization, potentiodynamic polarization technique. These are some of the important parameters as I told, coating, because when a metal is coated, to protect the metal from the corrosion, we need to understand the coating resistance, charge transfer resistance, double layer capacitance. These are some of the technical parameters, water uptake ability, finally corrosion rate. All these parameters can be analyzed with the help of impedance technique, electrochemical impedance technique. This is one such impedance parameter using a Nyquist plot. I am not going in detail on this. Yeah, lastly, I am going to touch upon the last part of my today's talk about corrosion prevention strategies, corrosion prevention methods. Yeah, when you are come across the corrosion prevention strategies, there are varieties of strategies nowadays used for the minimization, for the prevention of metal from corrosion, starting from design improvement. A particular design plays a most important role, particularly with respect to the corrosion of metal. The second one is a change of metal, because certain metals are used for certain applications. So this change of metals can be done by varieties of different ways. Either it can be done by change of composition of the metal, or it can be done by elimination of tensile stress. That is one of the important property of the metal. That can also be by means of change of microstructure. They are all metallurgical process, or introduction of surface compressive stress. So all these four properties of metals are associated with metallurgical operations. So making all these changes in the metals, we can control the metal from corrosion. And the third important protocol we normally follow to control the corrosion of metal is these three. That is a change of corrosive environment. So corrosive environment can be changed either by removing the corrosive constituents. As I told, oxygen is the main corrosive constituent. There are variety of other chemicals, acidic environment, alkaline environment, neutral environment. So all these, we need to remove this from the corrosive environment so that we can prevent the metal from corrosion. The second one is the use of certain inhibitors, corrosion inhibitors. There are varieties of corrosion inhibitors nowadays are in use to control the metal from corrosions, which can be added as an additive for the coating material. There are organic inhibitors, there are inorganic inhibitors, passivating inhibitors, cathodic inhibitors, film forming inhibitors. There are plenty of corrosion inhibitors nowadays or in wide applications to control the corrosion of metal. And also we can minimize the corrosion or prevent the corrosion by change of operating variables. They are the most important. There are plenty of operating variables. Say, for example, pH of the corrosive environment. If it is more acidic in nature, the metal is more prone for corrosion. Therefore, we need to change of temperature, because at high temperature, the metal is severely damaged. So therefore, we need to change the flow velocity of a corrosive liquid. We need to change. So these are some of the operating variables which are responsible for controlling the corrosion of metal. A fourth one is we can also prevent the corrosion of metal by changing the electrode potential. So the change of electrode potential can be done either by cathodic protection or by anodic protection. So these are the two techniques. And lastly, we can do it by use of coatings. Nowadays, we use a varieties of coatings. We can use a metallic coating, we can use a non-metallic coating, we can use a polymer coating, organic coating. There are plenty of coatings nowadays are in use for the control of corrosion or minimization of corrosion. Therefore, this is a skeleton which indicates the various protocol nowadays the technicians or metallurgists followed to prevent the corrosion of metals. So this I told about the design. What are the important designs which are responsible for metals to undergo corrosion? These to be avoided. Say sharp corners, galvanic corrosion, sharp bends. All these are responsible for corrosion. Alloying is one of the most important protocol. Mixing some stable metal with unstable metal. Say mixing some chromium nickel with iron, so that these are stable metals making alloy. So we can control the corrosion of metal. Therefore, alloy is one of the most important protocol we need to follow. Then organic coatings, inorganic coatings, polymer coatings, depending upon the requirement, depending upon the properties, depending upon application areas, we use corrosion. These are the various types of corrosion protocol techniques. So this is one of the most important kind of corrosion protection protocol called cathodic protection. So normally this type of corrosion protection protocol is followed by this technique. One such technique is called it as sacrificial anodic protection. So in this sacrificial protection, so this is a buried iron pipeline which is severely damaged because due to corrosion. So this can be prevented by connecting this iron pipeline with a sacrificial metal. So there are plenty of sacrificial metals, like we can use magnesium, aluminum, we can use other alloys. So these are most active metals. Once these sacrificial active metals are connected with this the corroding iron, so this portion is acting as anode, therefore it is getting corroded. This portion is acting as cathode. This is protected. So converting anode into cathode by connecting it to the sacrificial metal like this. So this is one of the most popularly used technique in buried pipelines, railing, so on. Another sacrificial protection technique we followed is impressed current technique. So it is just supplying external current by means of some source of power supply. Look here, again, this is a buried, underground buried pipeline. So where you are supplying the external power supply by connecting it to some inert metal as anode and this buried pipeline as cathode, that the supply of electron takes place.
Sir, Mohan sir.
Tell me, madam.
Time up, sir.
I will conclude in another 2-3 minutes.
Okay, sir.
So this is what we call it as cathodic protection technique. So there are varieties of other techniques. These are the various factors which are responsible for the kinetics of corrosion. As I told, one of the primary factor which is responsible for corrosion is the electrode potential of the metal. The varieties of the secondary factors which are responsible for the protection of metal is the pH of the corrosive environment. Is it acidic, neutral, or alkaline? Temperature is another important factor. So the use of corrosion inhibitors. These are varieties of corrosion inhibitors we used. Okay. So I don't touch upon this. Now I stop here for the first part of my talk, which includes the corrosion protection strategies, corrosion protection protocols. The corrosion prevention protocols by using varieties of different techniques. I will talk to you in my second talk, some of the recent developments. So with this, I'm just concluding my talk by the basic aspects of corrosion of metals and alloys is the most important subject in almost all material scientists, chemical scientists, physical scientists, mineral scientists, and so on and so forth. So dear participants, with this, my around 80 to 70 to 80 minutes of my talk. So if you need any clarification or if you want to any questions on my today's topic is concerned, please unmute your audios and you may please ask your questions.
Sir, I am Mehboob Ali ke Mullah.
Open for discussion. Yes, tell me.
A question, sir. Sir,
Yeah,
NK
tell me your
Mullah.
question. Yeah, tell me.
So regarding by means of power, we can control the.
Yeah.
By means of external potential or power supply, we can control the corrosion.
External current, not potential. External current. Yeah.
Is
Look
it
here, this is external
depends
current.
upon the power supply